5.8, Conductor Jamming, Chapter 9, Table 1, Informational Note 2. So here's your Table 1. Here's your percentages we talked about earlier. There's an informational note. It says that when pulling 3 conductors or cables in a raceway, because cables are considered conductors, if the ratio of the raceway, which is the inside diameter, to the conductor or cable diameter is between 2.8 and 3.2, jamming can occur. Now, Eric, what the heck is this talking about that jamming can occur?
Well, that's specifically when you have they say 3 conductors for a really good reason, because if you look at those 3 conductors, that's a great example. When you're pulling them through, those conductors are going to try to go side by side, and they're going to try to squeeze each other as they pass each other. And that's why jamming occurs with 3, but it's unlikely to occur with 4.
Yeah. Okay, and so what it's saying is that if you take the diameter of this raceway, which is 2.731, 2.5 inch EMT. Let's find out a diameter. How do we get the diameter of EMT? Isn't that table 5?
4.
Table 4. No, table 5, isn't it? No, table 4.
Table 4.
EMT.
EMT, and I'm looking for diameters. Oh, here's a diameter over here, right? Here's your diameter. And then I'm looking for, oops.
2.5.
Let's see, I'm looking for the diameter. And I'm looking for a 1-inch raceway if I had a straight edge.
2.5.
2.5.
2.5.
Oh, sorry, exactly. 2.5. I go across here. The diameter is 2.731, okay. So then I go to my graphic, 2.73, and then 500 kc mils, and that's going to be table 5. 500 kc mils. Leave my conductors. And what kind of conductor is that? THHN. So I think I highlighted already before, so that should make it easier. 500 kc mils, THHN. So I'll make it a little smaller. I have to make it so I can see which column it's going to be. It's going to be the diameter. It's going to go down here, all the way on the right-hand side. 500 kc mils to the right is 0.949. Is that right, guys? Looking at that table? 0.949 on table 5. And remember, video guys, put on pause as I work the different parts. You can't keep up with me, because I got to try to get this thing done in 5 hours or so. So back over here, we have the diameter of the raceway on Chapter 9, Table 4. We get the diameter of the conductors on Chapter 9, Table 5, including the insulation. And if I divide the diameter of the conductors into the diameter of the raceway, which would be the raceway divided by the conductor, comes out to be 2.8. And Table 1, Note 2, says that it occurred between 2.8 and 3.2, and we're right there in the perfect amount. Now, what I don't know is, what do we do? Like, okay. I mean, because it's an informational note, is that right? So that's not a requirement. It's just telling us that it can happen. Anybody, I mean, other than, hey, you're taking a test, they're asking you a question, what's the ratio of jamming, or give you an example. Have you guys ever had any experience? Yes?
I just think that this informational note shows the fact that you could look at what the table says, but in the field, you might want to go one size up.
You know what's interesting point, because Brian, you said something this morning. You know, I don't know, but sometimes I find out that if you put less wires in a raceway, it could be easier to pull, or if you put more wires in a raceway, and it looks like you're saying, if you get 3 wires in a raceway and you fit within the jamming rule, maybe you're better off putting less than 2.8 ratio, diameter, or more than 3.2 ratio, diameter. Go ahead.
Well, that's what I was going to say. I never intentionally calculated jamming prior to pulling because I didn't know about it. But after I found out about it, I was like, well, hey, let's look at what we already did. We know these 2 were a real pain in the rear end, and these 3 or 4 over here were fine. And we calculated out some of the stuff that we did, and we started looking at it and realizing, you know what? Sometimes a little bit less or a little bit more than whatever the ratio is actually works out better than you would think. And then you realize all of a sudden, actually every time, because, you're kind of in the same type of work usually as an electrician. So you're pulling the same sizes of services. You come up with your own little like tribal knowledge, I think we call it. Oh, I always run a 2.5 when I pull in a 200 amp service. And we don't know why. Well, because it's easier to pull. Well, then somebody gets the idea, well, bigger's better. So they put in a 3 and then they can't pull it in or whatever it happens to be. And you realize that this actually really is a true thing and it actually works out.
Well, as they're talking, my brain is going into this concept. This only applies when you have how many conductors in a raceway?
Three.
Three. Visualize this, 3 conductors in a raceway, and you start pulling around the first 90. It's going to automatically, inherently want to do what? To flatten itself out. Do you guys agree with that?
Yes.
And then when you pull it in the first 90, it's flattening the whole time. And once it gets inside it, it'll bounce around a little bit inside it, and all of a sudden it goes flat again, and then it gets hard, and it gets easy and hard. And then you get what? Then you get the jamming on one side, the jamming on the other side, where if we put the conductors a little smaller,
Yep.
well, a little smaller, then they would just flatten out.
Well,
Right? And if you put it a little larger, well, then they couldn't get flat. They would automatically have to, 2 gets in there, and then the other one kind of rides on top of that.
Right.
Total makes sense. So I think that information is a valid informational point. All right. Now let's go with an example. According to Annex C, Table C1, which is what? EMT, 3 500 kc mil THHN conductors can be installed in a 2.5 inch EMT. Will this installation have the possibility of jamming? Where jamming is between 2.8 to 3.2 ratio of conductors to raceway. Well, we go to Annex C1 and 2.5 inch raceway, 500 kc mil says 3. That should automatically ring a bell, right, Brian?
Yep.
3. Okay, once I do that, let me go find out, okay, what is the diameter of the raceway? 2.731. Let me get the diameter of conductors. 0.949. Let me do the calculation. 2.82. So in this case here, we probably want to put what? A 3-inch raceway. Especially if it's going to be a long run. Because you already have the friction, all the other things. Now maybe if you're going, so that's a great example to work it out. Yes.
Well, it's interesting
Right.
too, and this is just an aside, but sometimes if you put too large of a conduit in, it actually makes it harder to pull as well. And that's because the conductors are all flat on the conduit, so you have more friction instead of them, maybe only 2 conductors touching the conduit. So there's just a lot to know.
Okay.
Okay,
All
Mike.
right. Yes, Eric?
Yeah, so I've got a jamming spreadsheet, and it's specifically for EMT and THHN, and I'll just give you some sizes.
Okay.
For half-inch EMT, the trouble is 3 8-gauge,
Oh, that's cool.
okay?
I want to hear this. Hold on. So half-inch EMT, it's
3
8
8-gauge is
8 gauge.
jamming.
So we're all going to assume 3. So let's just go 8 gauge and half-inch.
Okay, 1 inch, okay, 3/4 inch doesn't have a problem. 1 inch EMT, 3.
3 gauge wire and 1 inch.
Okay, 1/0 in 1 1/4 inch, 3/0 in 1 1/2 inch, 250 kc mil in 2 inch, 500 kc mil in 2.5.
Hold on. 500 kc mil and 2.5. That's what I would have put in it. Right? I
That's-
would have put a 2.5.
And then my last one, well, and no one's ever going to run 1,000, but if you run thousands in a 3.5, that's jamming.
So, okay, go to the last 2 before the 1,000.
Okay.
What was the, before 500 kc mils?
Okay, there are 3, okay, 250 kc mil in
Okay.
a 2 inch, that's a
Oh, is that
problem.
right there? 250 kc mil in the 2 inch and 500
Yep.
in a 2.5.
Those are a problem.
Those are your problems.
3/0 in 1 1/2 inch,
Yeah.
1/0 in 1 1/4 inch.